Okay, so in Chapter 6, Section 1, we're going to talk about ionic and covalent compounds. First thing we're going to do is talk about how ions are made. And our learning goal here is write the symbols for the simple ions of representative elements. Okay, now as a background, it's important, I think, to appreciate that atoms lose, gain, or share electrons in order to acquire an octet, or 8 valence electrons in the formation of either an ionic bond, if they lose or gain, or a covalent bond if they share electrons. So really the whole goal is always to acquire an octet. What do we mean by that? All right, let's talk about that more. So first of all, ionic bonds occur, as I said in the previous page, when valence electrons of a metal, it turns out, when those valence electrons of a metal are transferred to the atom of a nonmetal. Okay, and when you get that, you're going to end up getting the metal is going to lose electrons, and so it's going to become a plus ion, and the nonmetal is going to become a negative ion, which we call an anion, and the cation and the anion are attracted to each other, and we call that attraction an ionic bond. Okay? Alternatively, sometimes you might get two non-metal atoms that actually share electrons, and when they share, we call that kind of interaction a covalent bond. All right, so let's look at some pictures of just what that means. So in this case, we've got a picture of a metal atom, okay, and a non-metal atom. And you can see the metal atom, in this case, has one extra electron. Let the black dot represent an electron. And if it has one extra electron, and if it donates it to a non-metal over here, which has 7, do you see those 7 there? Then all of a sudden, the non-metal gets an extra one, which makes 8, which is awesome. Okay, and the metal gets 0 in the shell that had 1 in it. Now this inner shell has 8. Okay, you can't see them, but it's there. And the plus and the minus are attracted to each other, and that makes the ionic bond. Okay. Alternatively, in covalent structures, what you get is two nonmetals. In this particular case, both of them have 7. Can you see that 7 black dots right there? Well, this nonmetal says to that nonmetal, hey, if you share that electron with me, then I'll have 8. And if I share mine with you, then you'll have 8, right? And so that's what we get. There, this nonmetal has 8, and this nonmetal has 8, right? And you see we still only have the same number, 14 electrons that we start out with, 2, 4, 6, 8, 10, 12, 14 electrons that we started with, but these two are shared, and we call that sharing a covalent bond. All right, so let's talk more specifically about ions now. In ionic bonding, ions form when atoms gain or lose their valence electrons to form a stable electron configuration. Okay, metals from group 1A or from group 2A or 3A will typically, number one, have low ionization energies. That is the amount of energy that it takes for an electron to be stripped from an atom. That's an ionization energy. So metal from group 1A, 2A, and 3A have low ionization energies. In other words, they readily lose one or more of their valence electrons to form ions with positive charges. All right? They lose electrons now until they have the same number of valence electrons as the nearest noble gas, which is typically 8 valence electrons. All right, a positively charged ion, which we're going to call a cation, is named simply for its element name. We do not change the name of a positively charged ion. We simply give it the name of the element. Okay, so here's an example. Sodium atoms, those are in group 1A. They're neutral. Sodium atoms are neutral, but they have 11 electrons and 11 protons. After they lose one electron, they have the same number of valence electrons as neon. And they also have a filled energy level. So here's the electronic configuration of sodium. And can you see that 3s1 right there? That electron in the third shell? Well, when that gets stripped away, then the outer shell is the 2 shell. And there are 8 electrons in the 2 shell after sodium loses its 3 shell. Okay? So after sodium loses an electron, it becomes a sodium ion, and we call it sodium. We call it the same name as the element. Here's another example for an atom from group 2A. In group 2A, magnesium is a good example of that. Group 2A, it has 2 extra electrons, right? So there's it is 3s2. Do you see it down there? 3s2. Well, those 2 extra electrons in the outer shell, if they get stripped away, if we pull those off, then it has the same electronic configuration as neon again, right? And you see those 8 electrons? All right, and that, because it has an electronic configuration of neon, it's happy, all right? And it turns out when it gives up those 2 electrons, it's left as a magnesium ion, which has a +2 charge. Now, negative ions are different. Negative ions are typically nonmetals, always nonmetals. And let's use examples from group 5A, 6A, and 7A. They have high ionization energies. That is, they do not want to give up an electron, right? They want to take an electron. So it's going to take a lot of energy to strip one away. It's basically not going to happen. They readily gain 1 or more valence electrons to form ions with a negative charge, okay? And then they're going to gain electrons until they have the same number of valence electrons as the nearest noble gas, usually 8, okay? A negatively charged ion, which we're going to call an anion, is named by using the first syllable of its element name and then putting the word or the suffix "ide" at the end. All right, so here's an example. If chlorine, which is in group 7A, it has 17 electrons and 17 protons. It has 7 electrons in its outer shell. Do you see that? 3s2, 3s2, 3p5. That's 7 electrons in its outer shell. If we give it 1 more electron, then it has 8 in its outer shell. 3s2, 3p6, right? And so it will have the same electronic configuration as, what is the, after chlorine, there's chlorine right here. It has the same electronic configuration as argon right there, right? Okay. Now, do you see how it has 7 electrons here? And if we add an electron to it, it has 8 now. It has its outer shell is filled, all right? And we don't call it chlorine anymore. We get rid of the ene and we put IDE. You see there it is right there, chloride. And that's how we name those. So table 6.2 in your textbooks has some examples of metals that make ions and nonmetals which take ions. And you see these all end in "ide," right? But the cations are all named as if they had the same name as the element that they came from. Okay, so just table 6.3 shows these in tabular form. Lithium, all group 1A. See, group 1A all have a +1 charge. Group 2A all have a 2 charge. Group 3A have a 3+ charge. See that? Now look at this. Group 7A has a -1, -2, and -3. You see that? It's no coincidence. Okay, also from your text, here is a table which shows some important cations in your body. Sodium, principally a principal cation outside the cell. Potassium is the principal cation inside the cell. How do we get sodium? Salt, cheese, pickles, hot dogs, right? Potassium from bananas, potatoes, orange juice, milk. Right, so a couple more examples, calcium and magnesium also. Let's finish this conversation out with a learning check. Please pause the video and do this and see if you get the same answer that I get. Okay, I'm going to suppose that you did pause it. What I'm going to do is I'm going to say my element here has 16 protons and 18 electrons, okay? So if it has 16 protons and 18 electrons, it must be a -2. It must have a 2- charge. Now let's go to the periodic table and find out what has 16 protons. 16 protons is right here. Looks like it's sulfur, okay? And so the structure we're looking for is S2-. Write the formula in symbol. Now we don't typically write the 16 down there because it's equivalent to the S, right? So you can put the 16 there. But this is the minimal answer for sulfide. Write the formula and symbol of an ion with 16 protons and 18 electrons, and there it is, sulfide. Okay, let's do the same thing here. Please pause the video and answer these 4 questions, A through D, and then compare your answers to mine. Okay, so let's suppose you had your chance to do that. let's identify either calcium and both calcium and chloride as either a metal or a non-metal. Let me come over here. Calcium is right here. You see it's in the blue range. That's a metal. Okay. So I'm going to come here and say that's a metal. And chlorine is a non-metal. It's yellow, right? So I'm going to say non-metal. Okay. State the number of valence electrons for each. Calcium is in group 2. So it has 2 valence electrons. And chlorine is in group 7. And so it's got 7 valence electrons. All right. Now, state the number of electrons that must be lost or gained for each to acquire an octet. Well, calcium is a metal, so it's going to want to lose 2 electrons, right? Let me change my color here for this. It's going to want to lose 2 electrons, and so that's what it's going to do. It's going to lose 2 electrons, and then its inner shell will have 8, right? Chlorine's a metal, a non-metal, so it's going to want to gain electrons. Well, how many electrons must chlorine gain in order to get 8? Looks like that's going to gain just 1. Right? And so that's going to give it 8. And finally, I know this is a little bit difficult to read, so big pardon. So finally, write the symbol, including its ionic charge, in the name of each resulting ion. So let me just come down here. Calcium's going to lose 2 electrons, so it's going to be calcium 2+. And chlorine's going to gain 1, so it's going to become chloride. And I'm supposed to write the name, too. So this is calcium, right? Oops, very ugly. Calcium. Because it's named for its element, but the anions are not, right? We drop the ending, chlorine, but we drop the ending and put IDE on the end. So that's going to be chloride for anions.